Tricky landings on Venus, future spacecraft. The best way to get to know the world is to visit it. Scientists have been studying planets and moons in our solar system for millennia and have been flying spacecraft past objects for years. But to fully understand these environments, researchers need to get their hands grimy, or at least a spacecraft's landing pad. Since the dawn of the space age, Mars and the Moon have had all the love of the land. Just a handful of spacecraft have landed on Venus, our nearest neighbor planet, and none of them have reached Europa, the icy moon of Jupiter, thought to be one of the best locations in the solar system to look for life. Welcome to Brainbender Solarium. Join us as we travel through space and explore spacecraft's future and what they will look like. In several talks at the virtual meeting of the American Geophysical Union, which ran from the 1st of December to December the 17th, planetary scientists and engineers explored new strategies that hypothetical future spacecraft would need to land on unknown terrain in Venus and Europa. Missions are still in the design process, not on the NASA launch schedule, but scientists want to be prepared. Venus is a world that is extremely difficult to explore. Its stifling temperatures and crippling atmospheric pressure have killed any spacecraft fortunate enough to hit the surface within around 2 hours of entry. The last landing was over 30 years ago, despite growing confidence among planetary scientists that the surface of Venus was once habitable. The prospect of past and maybe present life on Venus is one reason scientists are eager to get back. In one of the proposed plans discussed at the AGU conference, the scientists noted that tesserae were in their sights. Tesserae are geologically complex structures on the Venusian surface, photographed by the Magellan spacecraft. The images suggest a rough and blocky surface several meters high, reminiscent of a low-lying mountain range. Joshua Nicely said that safely landing in tesserae is absolutely crucial to satisfy their scientific objectives. Nicely is part of a research team led by geologist Martha Gilmore of Wesleyan University in Middletown, Connecticut, to plan a theoretical mission to Venus that could be launched in the 2030s. The space mission will involve 3 orbiters, a cloud float aerobot, and a lander capable of drilling and analyzing samples of tesserae rocks. This terrain is supposed to have been created where the edges of continents moved over and under each other a long time ago, bringing fresh rocks to the surface in what may have been some type of tectonic plate movement. This kind of resurfacing may have been necessary on Earth to make the planet friendly to existence. It may, however, be particularly difficult to land on Venus in these regions. The best maps of the planet from NASA's Magellan orbiter in the 1990s cannot tell engineers how steep the slopes are in tesserae terrain. These maps show that most are less than 30 degrees, which the lander could manage with 4 telescopic legs, but others may be up to 60 degrees, making the spacecraft vulnerable to overturning. In a conversation recorded for the meeting, Gilmore said that we have a very poor understanding of what the surface is like. What's the size of the boulder? What is the distribution of the rock size? We don't know the answers to these questions. The lander would need a smart navigation device to pick the greatest places to land and drive, but this need for steering presents another problem. Unlike landers on Mars, the Venus lander cannot use small rocket engines to slow down as it descends. The shape of a rocket is adapted to the density of air that is being forced against it. That's why rockets that launch spacecraft from Earth have 2 portions, one for the Earth's atmosphere and one for the near vacuum of space. Venus's atmosphere changes density and pressure so rapidly between space and the surface that dropping 1 kilometer will take a rocket that works perfectly to one that's misfiring and possibly blowing itself to pieces. Instead of rockets, the proposed lander would use fans to drive itself, much like a submarine, to turn the downside of the dense atmosphere into an advantage. The planet's atmosphere also poses the greatest obstacle to seeing the land's surface. The thick atmosphere of Venus scatters light more than Earth or Mars does, obscuring visibility of the surface to within a few kilometers. Worse than that, the scattered light makes it look as though the light were coming from all angles at once, as though a spotlight was shining in the fog. There are no shadows to help demonstrate the steep slopes or expose boulders that the lander might crash into. That's a big problem according to Nicely, because all the current navigation software is programmed to believe that light comes from only one direction. If we can't see the surface, we can't find out where the safe spot is. We can't do that with the current science. While possible solutions to the other landing problems on Venus are feasible, this one remains the biggest obstacle. Meanwhile, scientists and engineers are conducting elaborate practice sessions for a Europa landing, from modeling ice with various chemical compounds and vacuum chambers, to lowering a dummy lander called Olaf from a catapult to see if it stays. John Gallen, an engineer at the Jet Propulsion Laboratory, says that we have a criterion that the terrain can have any configuration, thorny, potholes, you name it. and that we must be able to adhere to that surface and be well adjusted at it. Olaf, the dummy lander, was named for his 4-year-old daughter's favorite character in the Frozen movie. During the past 2 years, Galen and his colleagues have tested various lander bodies, legs, and configurations in the lab by hanging the lander from the roof like a marionette. This suspension helps to mimic the gravity of Europa, which is 1/7 that of Earth. Without a lot of gravity, a huge lander might easily bobble around and damage itself while attempting to land. According to Galen, you would not stick the landing, you would bounce. His team tried bowl-shaped legs, sticky legs, springs that compress and drive into the surface, and legs that padlock to help the lander remain on various terrains. The lander can crouch like a frog or stand firm like a table, depending on the type of surface on which it lands. While Olaf is hard at work helping scientists figure out what it will take to create a good Europa lander, the project itself, like its Venusian equivalent, remains only on some planetary scientists' wish lists. Other researchers fantasize about voyages to different diverse worlds, like Saturn's Geyser Moon Enceladus. Some people will pick favorites, but everyone wants to land at some place that we have never been before. Thanks for joining us. We hope you found this video interesting. If so, take a look at some of our other videos you see on the screen now. Also, ring that bell to keep up with new content that we publish weekly. We'll see you next time, here on Solarium.